Is this the last solution available? We have 4 now, don't we? Let me just mention another one. A line, a point, and remember the area, beautiful concept of area of parallelogram. So I will take my point P, I will pick a point Q on the line, and I will make a couple of vectors. One vector, let's say from Q to P. And another vector is based at Q but follows the line. And then you can imagine that parallelogram. So why would I even think about parallelogram? So what is it that you want in that problem? Based on what we saw so far, you basically want to find the perpendicular from that point P onto line. We are interested in the length of that perpendicular. Well, then what I'm thinking is that a perpendicular from P to the line can be interpreted as the height of something. Maybe as the height of triangle, maybe as the height of parallelogram. And as I make this parallelogram, isn't the distance the height of that? So the distance is equal to the height. And can I compute that height? Is it a part of any formula, hopefully involving area? Isn't it the area divided by something? Oh, with base, right? Area is base times height. Do we know how to compute the area? Well, we have the formula, right? Do we know how to compute the base? Well, the base is the length of a vector. You know how to compute that. So both numerator and denominator are effectively computable. So we can compute the whole thing. Now, can we set up the whole thing algebraically? If I give you numbers, let's say P has coordinates 5, 2, and the line is y equals 2x plus 3. Can you pick a point on a line? Please do. Why don't you give me a point on a line? On that line.
0, 3.
0, 3. Can you pick another one? Can you pick 2 points on the line?
1, 5.
1, 5. Can you make a vector? QR.
1, 2.
1, 2. Does everybody agree so far? So I made a vector. Can you make a vector QP? QP. What is that?
Adding 1.
From Q to P, it makes 5 minus 1. Okay. What do we do to find the area? We take the two vectors together in one matrix. 1, 2, and 5 minus 1. And we will compute the determinant. The base is the magnitude of QR. That is square root of 1 plus 4. And that is finally minus 1 minus 10 minus 11 divided by square root of 5. And of course, we better treat distance as positive number. We usually do. So instead of the determinant, we'll probably take absolute value of that number. which will give us 11 over square root of 5. Isn't that a different solution? So I'll leave it for you to think about what's important here in this solution. How is it related to this one, that one? Can we bring all of them together? Can we see each of those solutions through the perspective of the other solution? And I think that's a good exercise for everybody just to try to do. Whether you complete it or not, it doesn't really matter. What I want is you to think about it and to try to figure out, and maybe to figure out another solution. Well, I think 5 is a good number. So, I think I'm done with solving this problem for now. We will come back to it. We will do another solution using Lagrange multipliers. If anybody knows what that is, it will be a new solution, multivariable solution, because there was nothing multivariable yet.